For the next lesson in our coordinate geometry section, we're going to take a look at the point-slope form of a line. And basically, the equations of lines come in many different forms. You know slope-intercept form already, which is y equals mx plus b. In that form, you can see the slope and you can see the y-intercept. But there's another common form that we need to take a look at, which you probably saw again back in algebra, and that's point-slope form. So point-slope form, just a quick little reminder, is when you have y minus the y value from a point that your line goes through, any point, and then that's equal to the slope times x minus the x value that your point goes through. And so in that equation, you can clearly see the slope, and then you can also see the point that the line will go through, which is the y1 value and the x1 value. And really, you can plug in any point that's on the line. So this is kind of a nice form of a line. So we want to explore a line whose slope is 2/3 and passes through the point 4, 5. So on the grid below, draw the line. The point 4, 5 has already been plotted for us, and we know that it has a slope of 2/3. So from this point, we can go up 2 units over 3, and we can do that a couple of times. And we can go down 2 units and back 3. And then we have our line. All right, now if you take a look, the thing about this line is that the y-intercept is not at a nice whole pretty number. It's somewhere between 2 and 3. So between what two consecutive integers must the y-intercept fall? We could say 2 and 3. But we know that the point -8, 3, -8, -3 lies on this line. And so what we want to do is find the slope between -8, -3, and 4, 5. So to go from this point here to that point there, it looks like I'm going to rise up 8 units and then run 12 units. So I'm going to rise 8 units, run 12 units. And so I can reduce that. I can reduce that down to 4/6. If I take a 2 out, I could have taken a 4 out, but I can reduce it again down to 2/3. So to go from one point to the next, I should be able to go up 2 units over 3 and hit points on my line. All right, so the next thing that we're going to look at with this one is, let me just scooch it up here a bit. It says, consider any arbitrary point xy that lies on the line. Explain why the following equation must always be true for the line. Then rearrange the equation so that there is no fraction on the left-hand side. And this is known as point-slope form. So if we know that y minus 6 over x minus 5 has to equal 2/3, then basically we're going to cross multiply here. So if I cross multiply, and then I bring the 3 over to the other side, so I divide everything by 3, I get y minus 6 equals 2/3 times x minus 5. And so this would be the equation of the line in point-slope form. So in this equation, I know that the slope is 2/3, and I know that the point would be 5, 6. All right, so now what we're going to do is we're going to rearrange this equation to get it into slope-intercept form. So we want to get y equals mx plus b. So I'm going to distribute the slope and then I'm going to add the 6 to both sides. And to add fractions, you need a common denominator, so I have to add 6, and all of my other fractions have a denominator of 3, so 6, if I want to make it have a denominator of 3, I have to multiply everything by 3. So that's going to be plus 18 over 3. And so now when I add those, I get y equals 2/3 x, and then minus 10/3 plus 18/3 is going to be a positive 8/3. And 8/3, if we think about that as a decimal, 8/3 turns out to be 2.6 repeating, or 2 2/3, which is a number between 2 and 3. Okay, so that would be the equation of that line. Okay, so on the back, point slope form, again, y minus y1 equals m times x minus x1, and then you can bring the y value over if you would like, so you can use that. So the first thing we're going to do is just use point slope form to write the equations of the following lines when we're given a point and a slope. So with this first one, we have y minus the y value of our point, and that's equal to the slope times x minus the x value of our point, and that's it. We can just leave it just like that. The next one, y minus the y value of our point is equal to the slope, and then times x minus the x value of our point, so x minus -3 would just become x plus 3. So try the next two and see if you can come up with those equations in point slope form. All right, so the next one is multiple choice, and the clue here says that you can sometimes use the point slope form of a line to help you get the slope intercept form. So the exercise says, which of the following is the equation of a line that's parallel to y equals 5x minus 3 and passes through the point 411. So we know that the slope of our new line has to be the same as this slope because the lines are parallel, and it has to go through the point 411. So given a point and a slope, I can easily write the equation of a line in point slope form. It's going to be y minus 11 equals my slope times x minus the x value of my point. But that doesn't look like any of these. So what I'm going to do is try to clean that up. So I'm going to add the 11 to the other side, and then distribute the 5. So I have y equals 5x minus 20 plus 11, and minus 20 plus 11 is a -9, which would be the equation of that line. All right, and then the last one, exercise 4, says segment AB has endpoints A and B, which are given. If a line is drawn through A that is perpendicular to AB, what is its equation, and what would its y-intercept be? So with this one, we have to write the equation of a line that's perpendicular to AB, but it has to go through point A. So the first thing I'm going to do is find the slope of AB. So I know my A and B values, so I'm going to do 9 minus 1 for my y values, and -4 minus 0. So remember, slope is y2 minus y1 over x2 minus x1. So I get 8 over -4, which is a -2. So the slope of AB is -2. So the slope of my new line has to be the negative reciprocal of this, so it's going to be positive 1/2. And I know that it has to go through point A. So really, I'm writing the equation of a line that has a slope of 1/2 and goes through the point -4, 9. And that's all I need to write the equation of the line in point slope form. And now I can just rearrange that to figure out what the y-intercept would be. If I bring the 9 over to the other side and distribute the 1/2, I get y equals 1/2 x plus 2 plus 9, and when I combine those, I get 11. So the y-intercept of my new equation is going to be 11. And that right there is the slope-intercept form of that line.